Today, we are going to be solving a problem that comes from the 2025 MIT Integration Bee. It says to evaluate the integral from 0 to 1 over 2025 of the infinite sum of 2025x raised to the k times e to the negative 2025x over k factorial dx. Before we get started, make sure you leave a like, subscribe to my channel, and let's get on with the solution. Okay, so my first impressions on this integral are that, well, it looks pretty complicated, but my second thoughts are, well, we have lots of 2025s and lots of 2025x's. So that makes me think that we should let u equal 2025x in the future. But for now, let's just focus on the antiderivative, and then we'll evaluate the definite integral later. Okay, so the kind of confusing part about this is that we have a sum inside of an integral. So we kind of have to just stare at the sum inside and then figure out what to do later. If you look at the sum long enough, you'll notice that this e to the negative 2025x term doesn't depend on the index k. That means we can pull it out of the sum. As k increases, the expansion of the sum is always going to have that e to the negative 2025x term. So we can take it out, right? So we can rewrite this as the integral of e to the negative 2025x times our infinite sum, the sum from k is equal to 1 to infinity of 2025x raised to the k power over k factorial times dx, right? Okay, so now is a good time to remember what we said earlier, right? We were saying how eventually we would want to let u equal 2025x and in order to simplify some things, right? So we let u equal 2025x. This means that du is equal to 2025 dx. It's pretty easy to see how our u is going to replace this term and this term, right? But in order to utilize the du, we have to multiply and divide by 1 over 2025, right? So we have 2025 dx and 1 over 2025 out front. So our 2025 dx is going to get replaced by du, right? So then we have our 1 over 2025 times our integral of e to the negative u, right? Yes, that's correct, times the infinite sum from k is equal to 1 to infinity of u to the k over k factorial dx. Or no, du, sorry. Okay. So now what we notice is that this infinite sum is really, really close to the power series for just e to the x, right? Okay, so we note that the power series expansion of e to the u is equal to the infinite sum from k is equal to 0 to infinity of u to the k over k factorial, right? Okay, so keeping this in mind, we want to know how we can rewrite this term using our power series expansion of e to the u. Notice that the only difference between the two sums is that this one starts at k is equal to 1 and the e to the u one starts at k is equal to 0. But we can pretty easily fix this by just plugging in k is equal to 0 into our sum and then adding the rest of the sum. So then we have that e to the u is equal to, if we plug in k is equal to 0, we get u to the 0 over 0 factorial plus the infinite sum from k is equal to 1 to infinity instead of just 0 of u to the k over k factorial. So then we have that our e to the u is equal to 1 plus our infinite sum, right? I'm not going to write all that stuff, okay? Just this is just this, okay? And so we can rewrite the sum as e to the u minus 1. And so we can replace our sum with just e to the u minus 1. Okay, so this means that we'll have 1 over 2025 times the integral of e to the negative u times e to the u minus 1 du. Okay, so from here it's pretty easy to finish. Okay, so we have 1 over 2025 times the integral, let's distribute, e to the negative u times e to the u is equal to 1. I hope you know that. And then we distribute again. We get minus e to the negative u du. Okay, so this last expression is actually pretty easy to find, right? You can split the integral and then do another u sub if you want. But what you're going to end up getting is 1 over 2025 times u plus e to the u. And then don't forget we have to add our c. And then from here we're pretty much done. Remember that u was equal to 2025x, so then our antiderivative is 1 over 2025 times 2025x plus e to the 2025x plus c. And then we're evaluating this from 0 to 1 over 2025, right? That's what the integration bee question asked for. So we can just ignore the c. And then we need to evaluate this from 0 to 1 over 2025. And then the arithmetic might be a little tricky, but let me just do it real quick, actually. So you should get, if you plug in 0, we get 1 over 2025 times 0 plus 1 over, yeah. So we get 1 over 2025 plus 1 over 2025e. And then if we plug in our 1 over 2025, we get, we should subtract 1 over 2025, right? And then this is equal to 1 over 2025e, and that should be our answer. And so we are done. Good job, guys. We did it. Thank you for watching the video. If you have any suggestions or critiques of my solution, please feel free to leave it in the comments. If you enjoyed this video, please make sure you like and subscribe, and I'll see you next time. Peace out.